Hello my friends and welcome again to my video channel. Today we continue our work on the YAESU FT221. Maybe if there are further surprises, I wouldn't be surprised if there are additional surprises in it. Next step is the alignment of the FM deviation and FM symmetry. So let's start. The first step is to check the 10.7 MHz output from the microphone amplifier, where also the FM oscillator and the other oscillators are on it. You can show it here on the diagram of the so-called mic amp. We see here the three crystals for the SSB, USB, LSB, CW, and here we have the FM oscillator and the modulation part, and I measured the output frequency here in pin 3. First in mode FM, it was a little bit off. Frequency 10.6997, and now I can adjust it exactly to the wanted 10.7 MHz in mode FM. That's important for the first setting of the FM deviation. The Groundhog Day. You know the movies from the 90s? The Groundhog Day. Bill Murray was the actor. He played a poor guy who came into a small community, and this community celebrated the Groundhog Day. And next morning when he wake up, they had another Groundhog Day. And so on and so on. And he had to suffer or to experience repeatedly the same day again. Groundhog Day after Groundhog Day. A nice story. I laughed about it when I saw it. But sometimes I couldn't laugh because I thought I'm laughing about myself. And now I have my personal Groundhog Day. This transceiver here is my Groundhog Day. See what happened. I just prepared the transceiver for setting the FM deviation. And then this happened, you see. PLL unlock. This PLL is driving me crazy. It is going bad again, or it is bad. And I can see it here. I took the PLL board on the extender and measured something around in the region where I assumed the problem is. And what I found is that this integrated circuit 703, this little amplifier here, is obviously faulty. I show you. This integrated circuit, it's a differential amplifier, is supplied from 8 volt via the 100 ohms, should generate 7.5 volts. I can measure here the 8 volt line, 7.96, that's okay, and behind the 100 ohm resistor I'm measuring 3.56 instead of 7.5. There is a voltage drop across this resistor, across this 100 ohm resistor, and here we should have 1.5 volt, and I can measure only what it is. Here it is 0.7 and 0.7 on both sides here in the input. So here's a problem. The resistor can be faulty, the 100 ohm, or the integrated circuit. Let's check the resistor. The transceiver is switched off, of course. So we can measure from this to this. 55 ohms in a reverse polarity. 55. So I think the resistor is okay, and the lower value is measured because we have on this side connection to ground and also here connection to ground. So next step is I will take out this integrated circuit, take it out of the circuit and measure then the voltage drop across the resistor, whether the resistor is okay, because then I have no load on one side. The resistor is then isolated on one side. The 703 is out. I used the desoldering pump and some solder wick. And now I can measure the 100 ohm resistor again. There is no load on one side, so the resistor is really isolated. And then we measure 100.5 ohms. I swap the polarity. Indeed, the resistor is okay, and I think the reason for the short we have is this IC. A second check: when this circuit is removed, we can measure the resistor on one side, 7.99, and on the other side also 7.99. So there is no short to ground. There's a ceramic cap in parallel, the second pin, but the ceramic cap has no short. I've never seen a ceramic cap with a short. They can lose capacity, that's possible, due to an internal contact problem. But a short, no, and there is definitely no short in this capacitor, so the problem indeed is this integrated circuit. The internal circuitry of this integrated circuit is more or less a differential amplifier. We have two inputs. This is one input and this is the other input. They go to these transistors. Here we have, as I see, it is a constant current source or current drain when we see it from this side here. The bias of this transistor is set by this one. Base collector connected, and another base collector connected is a bias for this one. And this is the same bias via an external 220 ohm resistor for this transistor. So these two transistors have the same biasing. And they have a constant current source or drain in the emitter. So they have a rather high gain, and the output is connected to this transformer. Torrey transformer, this input from the low pass filter. It's an 8 MHz filter. The frequency, the input is 8 MHz. So what can we do? I looked in the net for this circuit. You can imagine what happened. The price is beyond any discussion. $50 or similar. It's a price, the weight in gold. Don't pay it, I'm not crazy. I had another project with an IC201. That was the same integrated circuit. It's a 150 megahertz circuit, but we do not need 150 megahertz. We only have 8 megahertz. And I replaced it by an MMIC. This was possible because I had a low input impedance. Impedance is low input. Here we have a higher impedance. It's a low pass filter, so I cannot connect 50 ohms directly to it. I think I will look for a different IC, a so-called video IC, or any FM IC for 10.7 megahertz should be sufficient, or similar. There are no requirements regarding linearity or so, or maybe I will rebuild it with two transistors, maybe a third one as constant current source. See whether the gain is sufficient. I think yes, because there are no high requirements. I will think about it, look what I can find and what I can do to substitute this integrated circuit. For the moment now, I will stop this project. I don't delete this project, I will finalize it. I've invested too much time and effort in this transceiver. I don't give up. I hate that it will become a parts tornado only. No, it will operate. And I will finalize it. I only have to think about the solution with this integrated circuit. But this small, silly, stupid integrated amplifier will not be the death penalty for this transceiver. I will think about a solution. Maybe you have an idea, please tell me. Other projects are in my pipeline, so I will continue with other projects and then come back to this transceiver. So Stay healthy, stay tuned, and see you on this channel.